Today we're going to be talking about just some weights, some measures, metric system, things like that, and then getting into some common drug calculations. Just be aware that in the medical field, unlike the English system that we typically use in everyday life, we're going to be using the metric system, just a major system used in healthcare, just because of its simplicity. Units are determined just by a factor of 10, so you can easily go up, down, left, right, and whatnot. The basic units we're going to be using the gram for weight, the liter for measure of volume, and then the meter for the measure of length. So these are our basic units, and then we can modify them either up or down by factors of 10. When we modify our units, we're going to use these standard prefixes. So you'll see the kilo. So we're multiplying our base unit by a factor of 1,000. So 1,000 grams is 1 kilogram. You might also see a deci or deciliter. So we're dividing now our base unit, that liter. So 10 deciliters is 1 liter. You'll definitely be seeing centimeter. So 100 centimeters is 1 meter. We're dividing that base unit by 100. When we talk about milligrams, the milli, 1 gram is 1,000 milligrams. So we're dividing that base unit by 1,000. You also see micro. So 1 microgram, or excuse me, 1,000 micrograms is 1 milligram. So we're dividing again. So if you divide that base unit of a gram by 1 million, you get micrograms. So remember that 1,000 milligrams is 1 gram, and 1,000 micrograms is 1 milligram. You might also see nano somewhere. That's our base unit divided by 1 billion. Usually in the medical field you don't see that too often, but it might crop up here and there. Usage-wise, when you're writing down a number, we always use a leading zero if the number is less than 1. So for example, you're writing half a milligram, we're going to write 0.5 milligrams instead of 0.5 milligrams, just for ease of confusion. So you might write 0.5 milligrams, but someone else might see 5 milligrams, and that could be pretty dangerous for your patient when you're dosing out medications. Also, never use a trailing zero. So if we're writing 0.5 milligrams, it's not 0.50, or for example 1.250 milligrams. Again, that's just confusing. It's unnecessary. So always use a leading zero for less than 1, and never use a trailing zero, no matter what. Typical conversions that we're going to be making, both for temperature and weight. So first, we'll measure things in Fahrenheit, but you might see protocols written in Celsius. So there are the formulas to convert Fahrenheit into Celsius and Celsius into Fahrenheit. Then we are also going to need to convert pounds into kilograms. A lot of drugs are weight-based, so you need to give a certain amount of drug per kilogram for the patient to accommodate for the patient's weight. And so with our patients, they're either going to tell you their weight in pounds, or you're going to be estimating, and we are used to estimating weight in pounds. So to convert that into kilograms, roughly 1 kilogram is 2.2 pounds, so you can take the pounds and divide by 2.2. So think of that, 220 pounds is going to be 100 kilograms, 110 pounds is going to be 50 kilograms, but you might not always have a calculator right in front of you. So to divide that 2.2, kind of do a rough kind of 2 a.m. calculation where your eyes are bleary, you're kind of drowsy, and you don't have a calculator anywhere near you. Take the pounds, divide it by 2, and then take that number and subtract 10% from it. So if we have a 220-pound person, if we divide that by 2, I get 110, and then take that 110 and take 10% of that, which is 11, so I'm just moving the decimal place one space to the left. So I've got 11, so if I subtract 11 from 110, I get 99 kilograms. So again, this is kind of a rough calculation in your head, but it'll get you through, and it'll get you pretty close to the actual conversion. All right, let's get into just some simple medication calculations. Let's say you want to give a drug and you need to draw it up from a vial. You're going to be giving some amount of that drug, some X milligrams, and that vial is going to have a certain concentration. It's going to have Y milligrams in it, however many milliliters, Z milliliters. So let's say, for example, you want to give 2 milligrams from a vial that has 4 milligrams and 1 milliliter, and that's the concentration in that vial. So this might seem pretty straightforward to you, just looking at it to figure out how much you need to drop, but it's not always going to be so cut and dry, so obvious. So let's work through just this simple example, and then when you get to a trickier part, you can just take this setup and it'll work well for you. So I'm going to take this concentration, just 4 milligrams per milliliter, and what I want to give, I'm going to set them equal to each other, set them right alongside each other. So I've got 4 milligrams in 1 milliliter. That's my concentration in the vial. I know this, and I know I want to give 2 milligrams. What I don't know is how much I want to give. I want to give X. So we're finding for X right here. First thing we're going to do is cross multiply. So left to right multiplying, and this right to left multiplying on down. So I get 4x, so multiplying 4 times this denominator here, 4x, equals 2. And I get that from here, 2 times 1, 2. From there, we just solve for x, divide both sides by 4, and I get 0.5. And that's the milliliters that I needed to drop. So 0.5 milliliters will be my answer for this one. So let's do one that involves another step, an extra step, and maybe a little bit trickier for you. So we want to give 0.5 milligrams, and our vial has 200 micrograms per milliliter. So I need to figure out how many milliliters I need to drop from that vial. So first thing, we notice that the dose I want to give and the concentration that's listed on the vial are in different units. So I need to convert. That. So what I'm going to do, I'm going to convert these micrograms into milligrams. So just converting that, remember that 1,000 micrograms is 1 milligram, so this is less than 1,000. So we know it's going to be less than 1 milligram. So if we end up with more than 1 milligram, we know we've done something wrong. So we're going to divide this by 1,000, and we get 0.2 milligrams. So our concentration is both 200 micrograms per milliliter, and it is also in a different form, 0.2 milligrams per milliliter. So now we have our concentration. We can set that up on the left side, 0.2 milligrams on 1 milliliter, and I know that I need to give 0.5 milligrams. So I'm going to set that up on the right-hand side. And again, I don't know what I need to drop. That's what I'm trying to find out. So that's our x right there. I cross multiply. I can get 0.2x and then equals 0.5. Divide both sides by that 0.2 to find x, and I get 2.5 milliliters that I need to drop. So let's go through another one. Again, they're not all cut and dry and easily seen from afar. So I want to give 100 milligrams, and my vial that I pick up has 525 milligrams in 2 milliliters. So how many milliliters is 100 milligrams? We need to find that out. So take our concentration again, set that up on the left-hand side. In fraction form, we've got 525 milligrams in 2 milliliters, and I want to give 100 milligrams, and I don't know how many milliliters. I need to figure that out. So we're going to cross multiply. I get 525x, and then 2 times 100 is 200. Divide both sides by 525 to find x, and I get 0.38 milliliters. And let's just do one more simple calculation for practice. Let's say I want to give 0.25 grams of medication, and the vial I pick up has 3 grams and 2 milliliters. So let's take that concentration, set it up on the left-hand side. I've got 3 grams and 2 milliliters, and I want to give 0.25 grams. And I need to figure out how much I need to give. So let's cross multiply. 3x equals 0.5. That's 2 times 0.25. Solve for x by dividing both sides by 3, and I get 0.167 milliliters. I think we can safely round that up to 0.17 milliliters. Now let's talk briefly about solutions and what a solution is. When you see something on a bag or on a vial, lidocaine for example, you'll grab a bottle of lidocaine and it'll say it's a 2% solution. So what does that solution mean? Well, whatever that percentage is for lidocaine, that 2%, that tells you how many grams of that medication, that substance, is in 100 milliliters of fluid. So, for example, normal saline is a 0.9% solution. So that means that there are 0.9 grams per 100 milliliter of that normal saline. So if you grab a 500 milliliter bag, that means there are 4.5 grams in that 500 milliliter. We're just multiplying that 0.9 by 5. And likewise, that saline, or excuse me, that lidocaine, so there's a 2% solution, means there are 2 grams of lidocaine medication in that fluid, in that vial, per 100 milliliters. You'll also see D5W as a fluid that we can give intravenously. D5W is a 5% solution, meaning there's 5 grams of dextrose in every 100 milliliters of fluid that you have. And then we'll also be giving D50, which is a very concentrated solution for hypoglycemic diabetic patients. D50 is a 50% solution, which means there are 50 grams of dextrose per 100 milliliters. The amps that we'll be giving, those pre-filled syringes, are 50 milliliters. So we cut that 50 milliliters, cut the 100 milliliters in half to get the 50 milliliters. So let's cut that 50 grams in half. So you know that that pre-filled syringe is 25 grams of dextrose in that 50 milliliters. So anytime you see a solution, you see that percentage sign, you know that the number in front of that percent sign indicates the number of grams of medication per 100 milliliters of fluid. Say you want to start an infusion. So we're going to be setting up a bag. We're going to be hooking up our IV that we started up to some sort of IV line, what we call a drop set or drip set. There are two broad categories of drop sets. There are macro and there are micro. So the macro set, you're going to be getting 10 drops. That GTT stands for drops. So 10 drops per milliliter. So when you look at the drip chamber, which is right below the IV bag, that fluid bag that you've hung, for every 10 drops that you see drop down, that is 1 milliliter. Macro sets can also be 15 drops or sometimes 20 drops per milliliter. Your micro sets are going to be 60 drops per milliliter. So with the macro sets, we can infuse large amounts of fluid over a short period of time. So we really use these for hypovolemic patients. They need large amounts of, say, normal saline. They just need some sort of fluid bolus, fluid challenge. The micro sets come in really handy for medication infusions, like dopamines, lidocaines, cardazems. So the micro set allows us to titrate very finely. Since 60 drops for each milliliter given, we can really play around with the amount of medication that we're giving and have very fine control over it. So think the macro sets always using for fluids like normal saline, lactated ringers. The micro sets always using for medication infusions. We never want to see, say, a dopamine bag hooked up to a 10-drop set. That'll end very poorly for your patient because it's very easy to screw up the calculation and get the wrong drip rate. So how do we calculate how to set our drip rate? Well, for an amount of fluid that you want to give, the simple calculation is you take the volume that you want to infuse, multiply it by the drip set that you have hooked up to that bag, and then you divide it by the time in which you want to give it over. And that time is in minutes. So just for a simple example, say we want to give 1,000 milliliters of normal saline just over 1 hour, and we have a macro drop set hooked up to everything. So the volume to be infused, 1,000 milliliters. And this is always going to be in milliliters because we want milliliter and milliliter to cancel each other out. So if it's 1 liter, I'm going to convert it to milliliters. And we're going to multiply that by the drop set that I have hooked up, that macro. Say it's a 10 drop set. And then I'm going to divide that by 1 hour, which is 60 minutes. And I get 167 drops per minute. So this was a simple example. We're just giving normal saline over a given time. But let's take that concept. We're just giving some amount of fluid. Right? And all of our medications are in fluid form that we're giving through infusion. So let's talk about just a 3-step way to calculate that medication infusion instead of just a simple normal saline fluid bolus or something like that. So let's say we've got maybe lidocaine and we want to give 3 milligrams per minute. That's the infusion rate, the dose that we're giving. And my bag is 2 grams in 500 milliliters. So I'm grabbing that bag of lidocaine and I want to give 3 milligrams a minute. So it's a 3-step process. First thing I'm going to do, I'm going to find the concentration of that bag per milliliter. So taking that 2 grams per 500 milliliters and finding it per 1 milliliter. How much of that drug is in 1 milliliter. Second step, I'm going to find the amount needed of this concentration in the first step, needed for my 3 milligrams, that dose I'm going to be giving, 3 milligrams. And then the third step is we find that infusion rate. For that first step, I'm going to be finding the concentration per milliliter. So I've got this bag, 2 grams and 500 milliliters. So I need to get that down to just 1 milliliter and how much medication is in 1 milliliter. So the first thing we're going to notice is that the dose I want to give and the concentration, they're in different units. So I've got milligrams over here and I've got grams in my concentration. So I want to make those equal each other. So I'm just going to convert these 2 grams into 2,000 milligrams. Since 1 gram equals 1,000 milligrams, I've got 2 grams is 2,000 milligrams, just multiply by 1,000. So I've got 2,000 milligrams in 500 milliliters. And to find the concentration per milliliter, it's just simple division, 2,000 divided by 500. I've got 4 milligrams per milliliter, and that's the per milliliter concentration of the lidocaine bag that I just grabbed. Now that I've found the concentration per milliliter in the bag I'm using, I need to find the amount of fluid that I need for that 3 milligrams. So I've got 4 milligrams per milliliter. I've got the concentration in the denominator, and I want to find how many milliliters it takes for 3 milligrams. So put that in the numerator, divide by 3 divided by 4, and I get 0.75 milliliters. These milligrams cancel out. I'm just left with milliliters. So I know that I need 0.75 milliliters for basically 1 minute, right? I'm giving 1 dose, that 3 milligrams, and I want to get 3 milligrams per minute over an extended period of time. So in 1 minute, I'm giving 0.75 milliliters. And the last step to find my infusion rate, I've got my concentration. I found how many milliliters I need to give for just one dose of this 3 milligrams. So I need to find the infusion rate because I want it running over an extended period of time. So I'm going to use that calculation that we used earlier, the amount of volume to be infused multiplied by the drip set, and then all over the time to be given in minutes. So I've got my 0.75 milliliters right here, which I just found in the previous step. I'm using the 60 drop set, 60 drops per milliliter, because we're using a medication. We're giving that lidocaine. We want to use that micro set at all times, so I'm going to be using the 60 drop set. And then the time I'm giving this over, 1 minute. I'm using 1 minute because I found just a single dose, a single minute dose of this infusion. Remember, we're giving this infusion over a long period of time, but for this calculation here, the time that I'm giving this 3 milligrams over is 1 minute. So multiply this through, divide by 1, we get 45 drops per minute. Milliliters cancel out there. We're left with drops per minute, and that's what I'm going to set my rate to, whether you're using your eyeballs or an infusion pump. So we just went through the pretty standard medication infusion calculation that can be applied to a whole host of medications out there. When it comes to dopamine, we need its own calculation, its own formula. As you see, the dosing 2 to 20 micrograms per kilogram per minute. We need to adjust for our patient's weight with dopamine. So it brings with it its own formula we use quite often. The bag you're going to grab, the standard concentration is 1,600 micrograms per milliliter, or what we call just a 1,600 concentration. But definitely double check, triple check that your bag isn't. You might also see an 800 concentration or 3,200 concentration, so just double check before you get into this calculation and set this for your patient. To get our infusion rate, we're going to take the dose that we want to give. We're going to multiply that by our patient's weight in kilograms, multiply that again by our drop set, our tubing drip rate. And again, this is a medication, dopamine, a very vasoactive medication that we need to closely adjust and watch. So we're always going to be using that micro drop set, that's 60 drops per ml. This number, we're going to divide all that by the concentration in our bag. Again, 1,600 is the standard, but you might also see 800 or 3,200, so double, triple check before you just assume that it's 1,600. Let's say you want to give dopamine, you've got your bag, and you want to give 10 micrograms per kilogram per minute to your patient who weighs 220 pounds, and you do have a 1,600 concentration bag. So again, we're going to take the dose at 10 micrograms per kilogram per minute. We'll multiply that by my patient's weight in kilograms, so 220 divided by 2.2 is 100 kilograms. Divide that again by the drip set, and again, I'm using that micro set, 60 drops per ml, and I'm going to divide all that by the concentration in my bag, which is 1,600 micrograms per milliliter. A whole bunch of this cancels out, and we get 38 drops per minute as our answer. So there's one other way we can use for any medication infusion, no matter what, even if it's dopamine, no matter what medication, we can use this drip factor calculation. Really popular in hospitals. I learned it in critical care, and it just comes in really handy. Basically, you find a magic number, just this number that is you can use just very simply, and it's really helpful when not only setting up your infusion. It's about the same amount of work, same amount of math to set up the infusion. But when you're titrating your infusion either up or down, you don't have to do entire formulas all over again. You can just use this magic number and set your new rate in just a matter of seconds. So big assumption about this drip factor calculation, what we'll call drip factor. It always assumes that you're using a micro drop set. So you're always using a 60 drop per ml set. If you're not using a 60 drop set, you can't use this. Calculation doesn't work quite the way you'd like to. So just make sure for medications we should always be using that 60 drop set, a micro set, and this calculation assumes that. So just this three-step process to find your magic number. First, we're going to look at the dose that we want to give. Second, we're going to look at the concentration that we're dealing with in the bag, and then we're going to take that concentration number and we're going to adjust it as needed relative to the units that are attached to our dose. So what the heck do I mean when I say we're going to adjust the concentration number as needed and relative to my dose units? Well, take a step at a time. First, I'm going to look at my dose. I've got 3 milligrams per minute that I want to infuse. I'm going to take my concentration, 2 grams per 500 mLs. So first thing I'm going to do is turn those grams into milligrams. I want these units to line up. So turn those 2 grams into 2,000 milligrams. Second thing I'm going to do is take this number, this concentration number, and find the concentration per 1 milliliter. So just like we did before in our other infusion calculation, I want to find how many milligrams of this medication, this lidocaine, is in just 1 milliliter of fluid. And then lastly, for this bag, I'm going to be adjusting for time because the dose is per minute. I got 3 milligrams per minute that I'm infusing. If it was 3 milligrams per hour, I would not need to adjust for time. But because we have minutes, I need to adjust for that, which you'll see in just a second here. So like we said, first thing I'm going to do is turn those grams into milligrams. I've got 2 grams in 500 mLs as my concentration. That does not jive well with this 3 milligrams per minute of my dose. So I'm going to turn those grams into milligrams. So now the converted concentration is 2,000 milligrams in 500 mLs. Next step, we talked about finding the concentration per 1 ml. So just like we did in the infusion calculation before, I am just doing some simple division here. 2,000 divided by 500. And we get 4 milligrams per 1 ml. So there are 4 milligrams of lidocaine and just 1 ml of fluid. From here, I need to adjust for time because the dose is per minute, 3 milligrams per minute, and the hour is our base unit. So again, if this was 3 milligrams per hour, I would not need to adjust for time. But since it's per minute, I do need to adjust that for time. Since there's 60 minutes in an hour, I'm going to divide 4 by 60. And my final number, 0.0667, is my magic number. And this number doesn't carry with it any units of measurement behind it. It just stands alone. That's why it's a magic number. So write down that 0.0667 and we can use that. Now how am I going to use my magic number? I've got the 0.0667 as my magic number. I've got my bag hung. It's hooked up to my patient. I'm ready to set my infusion rate. So if I know the dose, then I will divide. So remember the term dose divide. And if you know the dose, then you divide. So I've got my dose at 3 milligrams per minute. So I'm going to take that 3. I'm going to divide by my magic number, 0.0667, and that's going to give me 45. So the number you get out of that division is always going to be your infusion rate, always going to be drops per minute. And you'll notice that that 45 drops per minute is the exact same number that we got from our original infusion rate calculation that we did earlier. Again, going back to our dopamine example and using the drip factor calculation, we can do the exact same thing, except we need to adjust for one more thing. So I'm still adjusting the units, but We don't need to do that because my units are already in micrograms, so we are good. I need to find the concentration per ml, but that tells me right on the bag, and I already know I have a 1600 concentration, so we already have that 1600 mics per ml, so we already have that. So the two things I need to do here is adjust for time, because it's per minute, and I also need to adjust for my patient's weight, because the dose is in kilograms. So we've adjusted for micrograms, everything lines up. Now we need to adjust for weight and adjust for time. So for this dopamine calculation, and the drip factor, that magic number, this is going to be per patient because we have to adjust for a kilogram. So the patient's weight is going to change. That magic number is going to change for dopamine if it's, or any drug that is weight-based. So first off, I don't need to adjust my units. We're good. My dose is in micrograms. My concentration is in micrograms. We don't need to do anything there. To find the concentration per ml, this is already done for us. This is 1600 concentration, so that's 1600 mics per ml. We're good there. So now I just need to adjust for weight and adjust for time. So if we adjust for weight first, remember in our example before, our patient weighed 220 pounds, we converted that to 100 kilograms. So 1600, take this, strip off the units now because they're useless to us. Take this 1600 and adjust and divide by 100 kilograms, gets us down to 16. And now I need to adjust for time since the dose is in per minutes. And remember, if it's per hour, we don't need to adjust since that's our base unit, but it's per minute. We do need to adjust. So 16 divided by 60, 60 minutes in an hour, is going to give us our magic number. We can stop there, 0.267. And remembering what to do with our magic number, if we know the dose, then we divide, and I do know my dose. It's 10 micrograms per kilogram per minute, and I know my magic number, so I'm going to divide the dose by my magic number. And do 10 divided by 0.267, and I get 38. And remember that the number you get out of that division is always your infusion rate, your drops per minute. So I get 38 drops per minute. And if we think back to our the longer dopamine calculation, this is the same exact number that we got. Now when does the drip factor calculation, that magic number, really come in helpful? If you're just setting an infusion and walking away from it, setting it and forgetting it, not titrating it at all, it's not going to save you any time. It's going to be the same amount of work as any of the other infusion calculations. But most of our medications we are going to be titrating. We are going to be adjusting either upwards or downwards based on our patient's response. So that's when the magic number comes in handy, because with that number we don't have to recalculate any of those long formulas when we want to adjust or change the dose that our patient is getting. We just do a simple division and we get our new drop number. So if I wanted to titrate that dopamine that we just dealt with from 10 mics per kilogram per minute to 12 mics per kilogram per minute, instead of redoing the long dopamine formula, I can just take the new dose, that 12, divide it by the magic number I had for that drug in that patient, and I get 45 drops per minute, and we can adjust that up from the 38 that we originally had. Same thing with the lidocaine. I originally had 3 milligrams a minute. If I wanted to titrate up to 4 milligrams a minute, instead of redoing the infusion formula, I can take the new dose of 4 divided by our magic number and titrate up to 60 drops per minute. And all those divisions just took a few seconds, and I didn't have to sit down and do any long formulas over again. In summary, what we just talked about, we did simple medication calculations, drawing some fluid up from a vial, figuring out how many milliliters you need to draw up from a vial. Talked about solutions and what that percent sign means. Talked about IV drip calculations, maybe giving normal saline over a period of time. Talked about 3-step infusion calculations for medications that we'll be giving indefinitely over time. Also talked about the special dopamine formula and dopamine calculations that you'll need. And then we talked about the drip factor and the magic number that you can find that comes in handy for titrating, both setting up infusions and titrating. We're going to be doing all these calculations and talking about all this throughout the semester when we're playing with our medications. So if you have any questions, please let me know. Otherwise, we'll be doing this in class over and over and over again. And if you're uncomfortable with it now, give it a little bit of time and you will be quite comfortable with it.